Hello, and welcome to this episode of Claranet Cybersecurity TV. My name is Alexi Bitsios. I am a senior penetration tester with Claranet's SBU, or Security Business Unit, also known as SEC1. In this talk, I'll be continuing with the OWASP Top 10 series, and I'll be talking about sensitive data exposure, or their A3 entry. So to briefly look at the agenda for this talk, I'm going to quickly go over what OWASP is and what their top 10 list is. Then we'll jump into the details of sensitive data exposure. Then we'll look at how we can identify such vulnerabilities. And finally, we'll wrap up with some prevention and remediation steps. So OWASP stands for the Open Web Application Security Project. I believe there is another episode in this series that goes into much further detail as to what they do. However, generally speaking, they are a not-for-profit organization whose sole purpose is to allow anyone to improve their cybersecurity and prevent themselves from being attacked and exploited. So the top 10 list that they create and update every couple of years is the list of what they consider the most critical web application security risk, and they like to call it an awareness document. So this is the top 10 list as it currently stands, and as you can probably imagine, today we're going to be looking at the A3 entry, which is sensitive data exposure. So sensitive data is something that's very difficult to define. It can be anything from credentials to payment information to personally identifiable information, cookies, medical records. The list just goes on. And the exposure of this can occur in a vast number of ways, but it can occur in two ways: in data storage or transmission. Now, due to recent legislation such as GDPR or the General Data Protection Regulation in the EU, this can lead to large fines, compromise of cyber assets, and a big damage to reputation if such incidents are not handled correctly. Now, looking at how we can identify such vulnerabilities, there's countless ways in which data can leak. You can have, for example, clear text credentials in a database, which if compromised, someone can just pinch them and just begin using them as is. They can use weak encryption or cryptographical ciphers. So, for example, if you MD5 a password, which say 10, 20 years ago would have been considered secure. These days, it's probably very easy to find the original clear text version of that, or there could be flaws within the actual encryption process. You have unencrypted communications. So when you visit a website, if you're visiting HTTP google.com instead of HTTPS google.com, all of the traffic to and from the web application are sending clear text, and anyone who is able to, who is suitably positioned to sniff network traffic will be able to see whatever data you're sending to and from that web application. You can also have incorrect permission set, for example. So think of an API. If we have an API where I can update an account's password, that should be restricted only to administrative accounts. But in the concept of sensitive data exposure, think about an API which returns medical records, for example. I should only be able to return my medical record. However, if I have an ID of 10 and I change the number 10 to 11 and that returns user ID 11's medical record, then we have led to a data breach. And this generally comes down to bad IAM or identity and access management implementations. So as was mentioned, there's two main ways in which data can be leaked or exposed, and that's at rest and in transit. And as mentioned, both need to be assessed. Perfect implementation, so you have the top grade encryption, hashing, identity and access management policies, etc., are absolutely fine. But then if you're sending the data over clear text, as discussed, over just clear text HTTP, then that data can be exposed. So the perfect implementation on one stage does not mean that you are secure. You need to ensure that both data at rest and in transit is secure. So looking further at how we can kind of identify these vulnerabilities, it's very important to analyze data transmission protocols and implementations and the configurations of these. So if we have, looking at HTTP as the example that we'll use moving forward, ensure that any HTTP connection is upgraded to HTTPS. And then once that has happened, ensure that everything, say cookies, session identifiers, etc., are reset so that any previous values are not then usable in the future. Review your data storage methodologies and processes. Ensure that secure data is, not secure data, that valuable data is encrypted or hashed correctly. And you don't have a file called password.txt that can be used to decrypt all of this data sat right next to the database. There's some very simple things that you can do. On top of that, think about data retention. If you no longer need that data, don't keep it. If you don't have it, you can't lose it. It's a very simple process. So if it's not going to be useful in the future, or you don't need it immediately, put it into cold storage. Put it in a place. If you really want to keep it, put it in a place completely offside of the internet and ensure it's heavily encrypted. Review the cryptographic algorithms and implementations that you are using. As I previously mentioned, there's a hashing algorithm called MD5. 10, 20 years ago, that would have been considered secure. That's no longer the case because it can be broken although it's a one-way hashing function, it can be broken within, say, 10, 20, 15, 30 minutes. And finally, assess your privilege levels and protections. A absolute basic user should not be of a, say, medical app, should not be able to list and view all of the medical records that are registered in a database. Say a maintenance worker shouldn't be able to do that. So if they shouldn't be able to do that, they shouldn't have that role. So identity and access management is something that's very important in this area. So now looking specifically at data at rest, we have weak or unsalted password hashes. So we've mentioned MD5. I'm not going to go over that. Again, there are several other now obsolete, well, considered obsolete hashing algorithms. And these are trivial to, and I echo this, decrypt with good word lists. And these weak password hash functions can be cracked even if salted. Salting is the use of a random set of characters which you put before the password. So say I want to register a user with a username of admin and a password of password123. If I was to hash password123, anyone else then hashing password123 would have exactly the same hash. So we generate a random value and prepend this to password123 so that the hash that is generated once this is the hashing function is complete does not have the same value as the other user. Automatic encryption. So DBMSs, or database management systems, automatically encrypt sensitive data, which is great. However, seeing as they automatically encrypt this data, they also automatically decrypt this data, which is not so great. So issues such as SQL injection, when you're, for example, you have an SQL injection in your web application and you're pulling data from a database, it will result in the threat actor acquiring the decrypted data, which is not good for you. So let's have a look at data in transit now. As discussed, looking at HTTP, which is a clear text protocol, over HTTPS instead of HTTPS, you need to ensure that SSL is forced on every authenticated page. If not, as mentioned, a suitably positioned attacker can monitor network traffic. They can wait for a non-SSL enforced page to be requested, downgrade that page to clear text HTTP, acquire your session cookie, and then they can just pinch that and use it in their browser session to use the web application just as you would. Unencrypted communications. It's a very similar scenario to the previous example. There's unencrypted communications that can be sniffed or modified. So for example, we want to do a bank transfer using a custom protocol that does not use encryption from, say, user 1 to user 10, and we want to send $5,000. I can, if I'm suitably positioned, I can send it from user 1, which is the victim user, to user 11, which is my bank account, and I can change it to, say, $100,000. And that, because the communication is not encrypted, that will go through, and that will suddenly take $100,000 from user with ID of 1. So let's look at some prevention and remediation steps. It's very important that you classify your data and identify any relevant laws or restrictions that need to be put in place. There are concepts such as PCI DSS, which is the payment card industry data security standard, which are, I believe, 12 steps which you need to follow and adhere to if you're planning on handling and storing payment card information. We also have GDPR, which is an attempt to give back control of data to individuals rather than companies. You should definitely apply relevant and necessary controls depending on the classification of data. For example, if data is publicly available, an About Us web page, there's no need to encrypt that. There's no need for you to provide a password or do something of the like. If you have a bank and you can conduct bank transactions, say send money from bank account A to bank account B, then you should definitely think about the data that's in transit and the data that's being stored, because this is considered sensitive data and it should be classified as such. And finally, again, just to drive this point home, don't store sensitive data unless it's necessary. What you don't have, you cannot lose, and it's as simple as that. If you don't have the data, you can't lose it. If you do have the data, you can lose it, and you'll end up in a world of trouble if you do end up doing so. So it's a very simple choice, in my opinion, at least. So you should also encrypt sensitive data at rest and for transmission. Use industry standard methods. Don't bake your own encryption or hashing protocol. There are some very well-tested and well-known protocols out there. Usually when you make your own protocols, etc., they end up having issues in them and can be cracked. And review your encryption and hashing methods periodically to ensure they're up to date and that they are the most secure that they can, or at least they are relatively secure enough for the data classification that you have applied to them. Don't cache sensitive data. It's a very important one. And finally, hash passwords, don't encrypt them. Hashing is a one-way function. It allows me to put in some text and a fixed length string will come out. And it's not possible to then use a key to decrypt that data. Use salt values so that, as we mentioned previously, if two users put the same password in, they don't end up having the same hash value. And then also implement a work/delay factor, because if a if a hashing function fails or a login process fails, then it might return much quicker than if it succeeds. So putting in a random delay of say 1 second to 5 seconds, even if the login process fails, will not allow an attacker to do a time-based attack. So once again, thank you very much for listening. My name is Alexi Bitsios, Senior Penetration Tester here with Claranet Cybersecurity Business Unit, and I hope you've learned something today.